دكتور
Yes.
بس في اسالك شو معنى infinite plane الصراحه ما فهمت.
Okay. Yana, if you look at the figure here, so just 1 second, let me open the problems again. Look, when they say infinite parallel plates, this means that in this direction you have an infinite length. Yani it's a very large length in the perpendicular direction to the paper, to the screen. Okay? Why? Because here, if you have a very long, if you want infinite or very long length in this direction, this means that your flow is not restricted. مش مثل in Y. In Y you have two plates. Okay? So due to the no-slip condition, from the no-slip condition of a fluid, because it's a viscous fluid, the velocity of the fluid will be constrained to have the same velocity of the plate. So if I have fixed plates, I should have same velocity here, which is 0. If I have moving plates, I should have for the fluid the same velocity of the plate. So in Y direction, I am restricting my fluid because the velocity at these 2 points is given by the velocity of the plate. So the plates will impose the behavior of my fluid in Y direction. While in Z direction, I don't have any constraint. I have a free flow if you want. It's infinite. I don't have boundaries which are imposing on me anything. This is why in Z direction, since no constraint, I will not have a flow in Z. Okay, so you will be only depending on Y and it will be independent of Z. This is the whole idea. Okay, so when I have infinity, this means that I don't have any constraint on my flow in Z direction. And here I only have constraint in Y direction, so you will vary with Y, but will not vary with Z. With Z, it will remain the same everywhere. Okay?
Okay.
So now, from my first equation, I get that del U by del X is 0. And this will tell me that I am in the fully developed region, okay? Because the variation of U is only with the perpendicular direction to motion, and I have no variation in U in the direction of motion. This is fully developed. So whenever I say fully developed, this means that in the direction of motion, no change of velocity. I only have change of velocity in the perpendicular direction to motion. Okay, so now from continuity equation, this is the result I got. From this result, as we said that since infinite plates, so it will not depend on Z. So I can deduce that U is only depending on Y. So U is only a function of Y. This is the conclusion I can make from continuity equation. Now I can move to Navier-Stokes equations. So here, since I'm working in Cartesian coordinates, X, Y, and Z, I will go to my formula sheet now. And I will apply these relations here. Let us go down. So now I can write my relations and start to simplify. Okay, I have a steady application, so this term is 0. I now demonstrated from continuity that del U by del X is 0. U is only function of Y. Now, for these terms, from the given V is 0 and W is 0, so these two terms also will cancel out. So now I can deduce that from the left side, I don't have any term. All of them will cancel. So in the exam, just put the equation and simplify. And just put this is 0 right here, since it is a steady flow. Like this, just one word, steady. Here, del U by del X from continuity. I demonstrate this from continuity. Here, from given, I have that V is equal to 0, and also from given, W is equal to 0. So this is how I justify how I eliminate my terms. Now, from the other side, what do I have? I have minus del P by del X. So I don't know the variation of pressure. I will keep this term. Minus del P by del X plus rho Gx. X is which direction? X is the horizontal, in the horizontal direction. So I know that G is vertical. Vector G is vertical, so no Gx here. And if I go to my figure, هن they named in vertical direction. What do we have? Let us look here. The vertical direction in my problem is y. So what can I deduce? I can deduce that g has only a component along y, which is minus g, no component along x and z, which constitutes the horizontal plane. So going back to my formula sheet, I will simplify gx and I will simplify also gz. I only have a component of g along y, and gy I can replace it by minus g, since y is upward and g is down. Now, if I continue simplification in my first equation, which is the linear momentum in x, we said that del u by del x is 0. We said that u is independent of x, so of course the second derivative also will be 0. So because already del u by del x is 0, so of course the second derivative is 0, since u is independent of x, and u is independent of z. So I will only have this term y, because we demonstrated together that u is only, so you can just write here u is only function of y. So I only have this term that will remain. Okay, so my first equation will reduce only to minus del p by del x plus mu second derivative of u with respect to y equals to 0. This is what I get from the first relation. Now let us move to the second relation. From the second relation, what do I have? First, v is 0 in my problem, so all of these terms will be cancelled since v is 0. Now, from the other side, I have minus del p by del y minus rho g, and also here, all these terms will cancel since v is 0. So I will only have these two terms, minus del p by del y minus g equals to 0. And now from the final equation, from the third one, I have also in my problem that w is 0, so all these terms will cancel. So as you can see, the equation seems complex, but when you apply to a problem, you have a lot of simplification. So all of this will be 0. So what you can deduce from the last equation, you only have one term. You only have that del p by del z is equal to 0. What does this mean? If del p over del z is 0, this means what? What can you
It
conclude
doesn't
from
change with the
gy
volume.
equals 0 كمان ولا؟
يعني ال P is independent of Z.
Very good. From this, you can conclude that P is independent of Z. This is the conclusion you can make here. Okay? So now I can say that, so P only function of what? X and Y. And let us see after how to continue with the pressure, how to know what is the pressure function. So now let me go back to my problem.
كده نطلع اليو with respect to y.
مظبوط. Yeah. Let us go to my problem and we will see what are the conclusions we will make. So here are the three equations we derived together. So all we have, these are the three equations derived using the Navier-Stokes equations in x, y, and z. So as we said, these are our results. Now we will start to simplify. I will start by making conclusion from the first relation. Okay, so now I will start to use the first relation to get what? To get u. Okay, so from the first relation, let me put it here. Okay, from the first relation, I have that the second derivative of u with respect to y is equal to 1 over mu del p by del x. Okay, so what can I deduce from this relation first? So just 1 second. Here also, before moving to u, from this equation of p, okay, del p by del y is equal to minus rho g. Okay, so I can say that if I integrate this relation, I can say that p is minus rho gy plus f of x, because I have already seen that p is independent of z. It's only depending on x and y. Okay, and by integrating this relation 2, I can get that p is minus rho gy plus a certain function of x, and this function of x is to be, I will determine it after. Okay, so if I derive this relation to get del P by del X. What do I get? I get that del P over del X is what?
دكتور فيك تعود ما فيك تجيب كمان دل بي باي دل اكس من فوق ايكوال لميو دل سكوير يو على دل واي سكوير.
مظبوط، هي del P by del X من فوق equal لميو del square U over del Y square. بس هقولكم ليش I'm doing this step, you will understand why.
كمان تعوضيها ما بدك تجيب هلا الديريفاتيف.
No. ما تسمعني شوي. أنا the whole idea that I want to demonstrate for you إنه P is independent of X. Why? Why it's independent of X? Because from the first relation, from equation 1, what do you get? You get that del P over del X is what? Is equal to mu times the second derivative del square of U over del Y square. Okay? إذا بس بستعمل هالequation I cannot continue. You know why? Because I don't know what is del P by del X. And if I want to integrate with respect to Y, how I will integrate del P by del X? I don't know. It might be a constant. It might be a function. So to be able to integrate this relation first, I should know what is del P by del X. And to be able to know what is del P by del X, I need to use the second relation. Because the second relation will help me, and we will see how, okay? When I do del P by del X from this second relation, I have, what is the conclusion I can make from the second relation? I can just say that del P over del Y is equal to minus rho G, okay? So now if you integrate this equation, if you integrate del P by del Y equal to minus rho G, what do you get? You get that the pressure P is minus rho Gy plus a certain function of X, because we said that P is function of X and Y. So if you integrate with respect to Y, you consider X as a constant. So this is why you will add plus a function of X. Now, let us derive now this relation, because what we want to find an information about del P over del X. If you do now the derivative with respect to X, Y is a constant for you. When you derive with respect to X, you consider Y as a constant. So the derivative of minus rho Gy is simply what? Simply 0. Plus the derivative of F with respect to X will give you dF over dX. Because F is only a function of X. And now you can say that del P by del X is only equal to dF by dX. What is the conclusion I can make from this? Who will tell me? If the derivative of P with respect to X is only a function of X, this means what?
يعني بس بدي اعمل لها انتجريشن كانه بنعتبرها كونستنت بتصير لانه هون with respect to y اليو.
مظبوط, with respect to y. From this result you can conclude so del P by del X is only function of what? Del P by del X.
ولا constant خلاص.
Del P by del X is only function of X. Okay? This is the conclusion you can make from this equation. And if del P by del X is only function of X, and in the first equation it's function of Y. And here, if you read this equation, del P by del X is mu del square U over del Y square. So from this relation, you say that del P by del X is only a function of mu, of Y, sir. Okay, so del P by del X is only function of Y. Why it's only function of Y? Because U is only function of Y. And now you have two opposing results, because the first equation tell you that del P by del X is only function of Y, and the second equation tell you that del P by del X is only function of X. So what is the only possible solution for this?
constant.
Constant.
Okay, so from these two results, because from the first result del P by del X is function of Y, and from the second result del P by del X is only function of X, so I deduce from these two, so del P by del X is constant. Okay, and now since I know that del P by del X is a constant, it will simplify a lot my integration. So now I can, when I integrate with respect to Y, I will integrate a constant. Okay, so now I can continue my problem to find what? To find the variation of U. So do you understand why I did this step before? Because when I want to integrate with respect to y, I should know if this is a function of y, yes or no. But from my analysis, I found out that this is a constant. So now I can easily integrate. Okay, so I can say since it's a constant, when I integrate, I have that the first integration will give me that du over dy is 1 over mu del p by del x times y plus a constant c1. And if I integrate another time with respect to y, I get 1 over 2 mu del p by del xy square plus c1y plus c2. Now, always
دكتور بس
always.
لحظة شو عملنا هون من بعد ما عملنا conclusion إنه
Okay, شو عملنا هون؟
دي by the
What
x
we
is
did
only
is we said it's a constant. Okay, so second derivative of u with respect to y is a constant. So now you can integrate. If you integrate the first time, since it's a constant, yani you keep it as it is and you multiply by what? By y. So du by dy is a linear with respect to y plus a certain constant c1. Now to find u, you should integrate another time. So if you have a constant times y, what is the integral of a constant times y? It's the constant times y square over 2. So when you integrate again, it's 1 over 2 mu del p by del xy square. Plus, when you have a constant and you integrate, so it becomes c1y. And don't forget to add at the end the constant of integration plus c2. Okay? So now you end up with two constants, c1 and c2. How to find these two constants? I need two boundary conditions for the velocity profile. What are the two boundary conditions for the velocity profile? Who will tell me?
يعني no slip condition.
Very good.
Bus max.
Always remember, for the velocity field, use the no slip conditions to find the constant. So here, if I go back to my figure, I know the conditions of velocity at two locations. What are the two locations where I know the condition of velocity?
At 0.
Lower plane.
بالنص
h minus h.
Naam, yes. At y plus h and at y minus h, what is my velocity?
اثنيناتهم زيرو.
ليش اثنيناتهم زيرو؟ لأنه the plates
لأنه
are
in
fixed.
contact with the plates constant.
Yeah,
fixed.
and the plates are fixed. So
Are
if
fixed,
the
yes, of
plates are
course.
moving, I should take the velocity of the plate. Okay, so I can say that u at plus h is equal to 0. Okay, due to since fixed wall, since I have a fixed wall and no slip condition and no slip condition. And at the lower bottom, so I have that u is, for the lower plate, u of minus h is also 0 due to the same reason. The wall is fixed and we have no slip condition. So now all I have to do is to apply at these two, at minus h and plus h, I will apply that u is 0. So I go back to my equation. Okay.
We don't
Now-
use انه at y equals 0 في عنا اليو max.
Yes, you can use this. You can say due to symmetry, I have the maximum at the middle, exactly. And then which condition you use if you want to use this?
ده اليو بدل واي equal
Exactly. So another
zero.
possibility due to
equal,
symmetry,
zero.
yes. Another possibility, you can say that du by dy is equal to 0 at y equals 0 due to symmetry. Okay, so from this you can deduce that, from this condition, you can deduce that cy is what? C1. C1 is 0. So C1 is 0. And you can find out this result if you use also the other condition. So the two will give you the same results. Okay, and now to find C2, I can apply or at plus h or at minus h, as you like. So for example, if I take at plus h, okay, and I replace in my relation, what do I get? I get that 0
maximum.
0 is equal to 1 over 2 mu, 1 over 2 mu times del p by del x, okay, times h square. And T1 is already 0, so it will cancel out. So plus C2. Okay, plus C2 then I can deduce the value of C2. So C2 is minus 1 over 2 mu times del P by del X times H squared. And now I found out my constant C1 and C2. Replacing back, I can get my velocity profile. So my velocity profile is parabolic. It's a second degree function of y. It's 1 over 2 mu del P by del X times y squared minus H squared. Okay. So I got my profile. I am done with the velocity profile. I still need to finish the pressure profile. Okay. So for the pressure profile, what I know until now is the following: that P can be written as P equal minus rho gy plus f of x. Okay. How to continue now? To continue, I should use the result that del P by del X is a constant. So we already said that del P over del X is a constant. So now, if you derive this relation with respect to X, what do you get? You have minus rho gy is only function of y, so 0, plus what? Plus df by dx, plus df over dx. Okay? So you can say that to find your function f, you need del P by del X. Now, how to get del P by del X? They should give you additional information. Okay, they should give you the pressure drop over a certain length. So for example, if they tell you I will take 2 sections and the distance between these 2 sections is L. If they don't give you anything, no problem. You can just express function of del P by del X. You say that del P by del X is a constant and you find f function of it. But if they give you, for example, that I have P1 here and P2 here, and the distance between them is L, you can say that del P by del X is equal to del P by del X is equal to the variation of pressure, which is P2 minus P1 over delta X, which is L. Okay, and sometimes in other words we say it's minus delta P over L. Why we put minus delta P? Because pressure will decrease. We call it pressure drop. Why we will have pressure drop? Due to loss of energy. Okay, so this is equal to delta P if you want minus pressure drop minus pressure drop over L. So in general, they give you the pressure drop delta P. Okay, so you can say that del P by del X is minus the pressure drop over L. So now,
Okay.
yes.
مين قال لنا انه هي لينير حتى نعملها دلتا اوفر دلتا؟
لأنه دي P by dx is constant. مش هيك؟ مش نحن قلنا إنه دي P by dx is constant. What does this mean? If del P by del X is constant, يعني the variation of P with X should be linear. ما هيك؟
Okay.
Okay. So as you can see here, del P by del X is a constant, is equal to the derivative of F with respect to X, which is minus the pressure drop over L, a distance L. برجع بقول لكم إذا ما عطيوكم delta P over L, you can keep it as function of del P by del X, which is a constant. So now, if you integrate with respect to X, you find out that what is F? If you integrate this relation, it's del P by del X, which is a constant, times X plus a certain constant P0. So if you replace back Fx by its value here, you get that P is minus rho gy plus this is F del P by del X times X plus P0. And if they gave you the pressure drop, you can replace del P by del X by minus delta P over L. Please pay attention here, it's a typing error. يعني هون ما في del P by del X again, because they replaced del P by del X by what? By minus delta P over L. Okay? And what is P0? P0 is a boundary condition. If they tell you, for example, for X equals 0, Y equals 0, P is given to be P0, then your constant here will be P0, because for X equals 0 and Y equals 0, your pressure is equal to P0. Okay? So in this way, we have determined what is the pressure function. Okay, this is the pressure function. It's minus rho gy minus del P over Lx plus P0. So you can see that P is, yalla, I will answer all questions, just 1 second. So P is varying in a linear way with Y. This is the hydrostatic pressure, okay? It's minus rho gy. And in X, it's varying due to the pressure drop. Yes, tell me.
ترجع تعيد بليز صار اخر الداتا ستور
نعم.
من عند
Yes. Okay, I will repeat.
gradient.
Yes, I will repeat. Okay. First, you understand how we found this. هيدي من وين جبناها minus rho gy plus fx? From here. If you go back to your equations here, from the second equation of pressure,
Yes.
we got that del P by del Y is minus rho g. Okay? Then we integrated with respect to Y. What did we get? We got that P is minus rho gy plus fx. Okay? So until now, this is what we know. Plus, we demonstrated together that del P by del X is what? Del P by del X is a constant. Okay? It's a constant. And if you derive this equation with respect to X, what do you get? Derive del P by del X from here. What do you get? Minus rho gy is independent of X. Because when you derive with respect to X, you consider that Y is a parameter, that is a constant. So this term, when you derive with respect to X, will cancel out. You will only have the derivative of F with respect to X. So you can say that del P by del X is equal to constant, is equal to the derivative of the function F with respect to X. Okay? So what can you deduce now? You can deduce that dF over dx, dF over dx is simply equal to the constant, which is del P over del X, times what? Times X, because when you integrate, sorry, here I want to integrate. So I want to find F. So the function F, when I integrate, since it's a constant, so I put the constant times X plus a certain constant to find. Okay? So now what will be the form of my pressure? P is equal to minus rho times G times Y and plus del P over del X times X plus a constant. How to find the constant? For the constant, they should give you a boundary condition. So for example, if they tell you for X equals 0, if they tell you in the given that for X equals 0 and Y equals 0, we have that the pressure P is a certain value P0. So now if you replace in your equation for X and Y by 0, what do you get? So for this condition, P is equal to 0 plus 0 plus P0. So what will be my constant? So my constant is equal to P0. Okay? So sorry, it's 0, 0 plus the, to be accurate, 0, 0 plus the constant should be equal to P0. So what is my constant? So the constant is equal to P0. Okay? From here, you can determine your pressure relation. Now, I told you if they gave me the pressure drop, and since del P by del X is a constant, so I can calculate del P by del X as it's minus the pressure drop, delta P, okay, minus pressure drop over the distance L over which I have this drop. If they gave me values, I can replace del P by del X by minus delta P over L. And if they don't give me... نعم.
ليش minus pressure drop مش plus؟
لأنه هن مزبوط، هن أنت قصدك إنه دلتا بي هي P2 minus P1، بس هن معتبرين إنه بس يقولوا عم يحكوا ببريشر دروب كأنه عم ياخذوا الابسوليوت فاليو. أوكي؟ يعني هن قصدهم بدلتا بي مش P2 minus P1، قصدهم the value of the drop of pressure. بس معك حق، يعني in general we use delta P as P2 minus P1. So إذا أنت أخذها P2 minus P1 ما بتحط minus. أوكي؟ إذا أنت أخذها P2 minus P1 you don't put minus. هن أخذينها كabsolute value. This is why they put minus.
خلص احنا ناخذ دلتا بي اوفر ال.
خذوها مثل ما بدكم، المهم تكونوا إذا بدكم تاخذوها دلتا ساعتها بتكتبوا إنه دي بي dp over dx اذا مش اخذينها كابسوليوت فاليو بتكتبوا دلتا p over n. اوكي وهي p2 minus p1 بتطلع نيجاتيف. اوكي equal to
هاي ريليشن دغري فينا نستعملها رايت؟
اكيد. لا فيكم دغري تستعملوها من بعد ما تثبتوا انه p is dp by dx is constant يعني p is linear with x. So dp by dx is p2 minus p1 over n. او اذا بدكم هن حاطينها ماينس لانه اخذين الابسوليوت فاليو يعني هن اخذين كانه كاتبينها هن ماينس p1 minus p2 minus p1 minus p2 over n. So it's just a way of writing, but the result is the same. dp by dx will be negative. Okay, it will be negative because we have a pressure decrease with x. Okay. Any other question on this?
Thank you, doctor.
Okay, just if you can give me 5 minutes to continue this problem for you. Okay, so now after we have done this, they asked for the flow rate, the volumetric flow rate per unit width. When they say per unit width, yani I take in width length equal to 1. Okay, so how to calculate the flow rate, the volumetric flow rate? You know that dq, the elementary flow rate, is u times what? Times dA, the elementary area. And how to choose my elementary area here? Let me go back to the figure. Here you should do integration. Why you should do integration? Because u is variable. Okay, and here because u is varying with y, u is varying in y direction, so you should integrate. You should integrate in y. So your elementary area dA will be like this. You take a small thickness along dy, and since they asked for unit width, you take a width of 1. Okay. So what will be your elementary area here? dA will be equal to the unit width 1 times the thickness, which is dy. Okay. So dA is simply equal to dy. So you can just say that I will integrate u dy. From what to what you should integrate to cover your velocity profile? Y is varying from what to what?
-h to h.
Exactly. It's varying from -h to +h. Okay. So now if you integrate...
فينا نقول 2 times 0 ل h.
Oh, 2 times. Very good. You can do 2 times integral from 0 to +h due to symmetry. Because you have a symmetrical profile, what you can do, you can calculate from here to here and multiply by 2. Also, it's another possibility. Okay. So now, if I go back to the calculation here. Okay. So here they integrated from -h to h of your functions. The integral is very simple because this is a constant. The integral of y squared is y cubed over 3. And this is a constant, so the integration is -h squared y. And then you replace by the boundaries, you can get the value of your flow rate. Okay. Now, to calculate also the maximum velocity, they asked for the maximum velocity. When you get your expression, you can deduce the maximum velocity from which location? Where do I have the maximum velocity?
At 0.
على الميدل. Okay. هلا if you didn't pay attention, when they ask you for maximum velocity, you can say that it's obtained for del u by del y equals to 0. And if you put del u by del y equals to 0, it will give you that this will happen at y equals to 0. So at the center line, which is expected because the maximum will be at the center because I have a symmetrical flow. And it's starting from 0 at the 2 walls because I have the no slip condition and my walls are fixed. So from here, if I replace in the expression u function of y, if I replace y by 0, I can get my maximum velocity. Okay. And sometimes also they ask for what is called average velocity. If they ask you for the average velocity, how you calculate it? Who knows? How to calculate the average velocity? What should I do? When they ask you for the average velocity, it's very simple. You just take the volumetric rate over what? Over the area. So here we have calculated together the volumetric rate for a certain, for the flow. We should divide it by which area here? نحن مش جبنا الاريا per unit
باي اتش
width
سكوير.
يعني for this area مش نحن اخذنا عنا هون a total height of 2h and a width of 1 مزبوط. مش نحن جبنا ال volumetric flow rate per unit width يعني what is the area, the corresponding area هي 2h times 1. So if we divide the Q by, we found together by 2h, we can get the average velocity. And here Q is by definition the volumetric flow rate per unit width. Volumetric. This is the one we calculated together. Flow rate per unit width. Okay. If we divide it per the corresponding area, total area, which is 2h times 1, we can get the average velocity. And of course, the average velocity will be between 0 and the maximum velocity. So you can verify your calculation from this. So if we look here at this in this problem for the values, you will get that U maximum, if you calculate it, which is correspond to y equals 0 at the center line, it's minus h squared over 2 mu del p by del x, while the average velocity, by dividing q here by 2h, you get that the average velocity is h squared delta p over 3 mu l, which is smaller than u max. So you can, if you do the ratio, you get that u max is 1.5 times the average velocity.
اوكي مين قال لنا الويدث 1؟
نعم هن سألونا
مين
per
قال؟
unit هن قالوا لنا per unit width اصلا here length لجوا is infinite يعني مجبورين يحددوا لك length يعني per unit width it's a general relation لانه انت length is infinity لجوا. اوكي يعني you can calculate the volumetric flow rate per unit length. ساعتها اذا بعطيك 10 meters you multiply by 10 to find the corresponding flow rate. بس أكيد ال velocity average وال maximum are independent of the width. يعني whatever is the width you take, you will obtain same U max and same average velocity. لأنه you don't have variation in depth in G. Okay. Any other question on this? Please try to do problem 4. Problem 4 نفس الconcept تقريبا بس for polar coordinates. So you can apply the same rules we have seen in this problem for polar coordinates. And if you need any other extra problems or you need any other help, we can do office hours whenever you want, or you can send me your questions by WhatsApp. Okay. And if you want to do an extra session, I'm ready, but not Friday, because Friday you will not have the time. Yani. If you have time tomorrow, I don't have a problem. Just tell me. You can tell me on the group if you have availability. If not, you can just send me your questions by WhatsApp whenever you know. Okay?
Doctor?
Yes.
Are we not going to do problems on temperature?
Yes, if you want, this is why I'm telling you we can do an extra session. You can do it now, or we can do it tomorrow as you like.
في the last two problems but chapter 7 ما عملناهم.
Okay, طيب. We can خلينا على الجروب نحدد session and we do that. Okay.
Okay, doctor. Thank you.
Yeah.
Okay, thank you, doctor.
Bye.